Let's look at example 3. We need a third degree polynomial, so I need to go down to the third derivative. And it's Maclaurin, so I know that my c here is 0. I'm centered at 0. Just like last time, I make that table to keep myself organized. I have f of x is equal to x squared e to the negative x. Let's find the first derivative. Notice this is a product, so I will need to use the product rule. F prime of x here is going to equal the first times the derivative of the second. Well, the derivative of e to the negative x is negative e to the negative x. So the first times the derivative of the second plus the second, which is e to the negative x, times the derivative of the first, which is 2x. To make the next derivative a little bit easier to find, let's factor out an e to the negative x from both of those terms. If we were to factor out an e to the negative x, we'd be left with x squared times a negative, or negative x squared, and then just plus 2x. Now this is easier to find the derivative of. It's also a product, so I do need to use the product rule. It's going to be the first e to the negative x times the derivative of the second. Well, the derivative of negative x squared plus 2x is negative 2x plus 2. Plus the second, negative x squared plus 2x, times the derivative of the first. Well, the derivative of e to the negative x is negative e to the negative x. Factoring out an e to the negative x so that it's easier for us to find the next derivative, we'd get e to the negative x, and then here it's just negative 2x plus 2 that's left over, and here I have a negative and then a negative x squared plus 2x. We're going to want to distribute that negative and then combine like terms. That becomes a plus x squared minus 2x. Combining like terms, we get that this second derivative is equal to e to the negative x times x squared minus 4x plus 2. Let's find the final one, the third derivative. The third derivative, we're still using the product rule, is going to be the first times the derivative of the second, which is 2x minus 4, plus the second, x squared minus 4x plus 2, times the derivative of the first, which is negative e to the negative x. If I again factor out an e to the negative x, I have 2x minus 4 left from the first one, and here remember it's going to be a negative in all those, and what happened there is that we just ended up having to switch the signs. So let's go ahead and just switch the signs to save a step. This is going to be a negative x squared, a positive 4x, and a negative 2. Combining like terms, and we get that the third derivative is equal to e to the negative x times negative x squared plus 6x minus 6. Now we need to evaluate each one of those at 0 because we're finding that Maclaurin polynomial. What is f of 0? Well, that's just going to be 0 squared times e to the negative 0. If you put that in a calculator, you get 0. Going to the next one, f prime of 0 would be e to the negative 0 times negative 0 squared plus 2 times 0. If you stick that into a calculator, you get 0 again. For our second derivative evaluated at 0, we'd have e to the negative 0 times 0 squared minus 4 times 0 plus 2. Again, if you stick that in a calculator, you'd end up with 2. Finally, that third derivative evaluated at 0 would be e to the negative 0 times negative 0 squared plus 6 times 0 minus 6. Sticking that into a calculator, we'd end up with the third derivative at 0 is negative 6. Now let's build that third degree polynomial. P sub 3 of x is going to equal 0 times x minus 0 because I'm centered at 0. This is the 0th derivative over 0 factorial plus 0 times x minus 0 because you're centered at 0 raised to the first because that's the first derivative over 1 factorial plus 2 times x minus 0, again you're centered at 0, squared because it's the second derivative over 2 factorial, plus negative 6 times x minus 0, again because you're centered at 0, cubed because it's the third derivative over 3 factorial. Cleaning this up, I know this is going to be 0 times something and 0 times something, so I know that these first two terms are just going to cancel. Then if I clean this up, I end up with 2 x minus 0 squared is just going to be x squared. 2 factorial is just 2. And then plus a negative is minus 6. X minus 0 cubed is x cubed over 3 factorial is 6. And then if we reduce the numbers, p sub 3 of x is going to be x squared minus x cubed. Let's go ahead and look at this in Desmos again just to kind of see what we're doing. Again, what we're doing is making a function look like a polynomial. The function in this case was x squared times e to the negative x. And we want it to look like a polynomial, and the polynomial that we got was x squared minus x cubed. Now again, notice we're agreeing at 0 and we're agreeing with the slope. The more terms we'd have, the more the blue graph, that blue polynomial, would look like our given function. Let's look at the last two examples where we're finding the nth Taylor polynomial for the following function centered at c. This time, it's a Taylor polynomial. It's centered at c, so we'll be given what we're centered at. It won't be 0. This is a fourth degree polynomial, so I know I need to go down to the fourth derivative. Let's make that table to organize ourselves. So the given function is 1 over x. Since I need to take its derivative, let's rewrite it with a negative exponent. Let's write it as x to the negative first. Now, what's the first derivative? Well, that's going to be negative x to the negative second. Second derivative, positive 2x to the negative third. Third derivative, negative 6x to the negative fourth. Fourth derivative. Now notice after the third derivative, we stop using those little tick marks, and we denote a derivative by putting a superscript number in parentheses. So this means the fourth derivative. Recall before we were calling this the nth derivative. So this is the fourth derivative of x, and it becomes 24x to the negative fifth. Now let's find the value of the function at each one of these. So I need to find f of 2, because again, we're centered at 2. So what is 2 to the negative first? Well, sticking that into a calculator, you'd get 1/2. F prime of 2, what is negative 2 to the negative second? Again, you'd stick that into a calculator, and if we show that real quick, negative and then 2 to the negative second, you'd get an answer, and what you would do is you would make it into a fraction, and you'd have negative 1/4. F double prime of 2, 2 times 2 to the negative third, stick it into a calculator, you'd end up with positive 1/4. The third derivative at 2, negative 6, 2 to the negative fourth would be negative 3 over 8. And the fourth derivative at 2 would equal 24 times 2 to the negative fifth. Put that in a calculator, make it back into a fraction, and you get 3/4. Now let's build that fourth degree polynomial. We know that p sub 4 of x is going to equal 1/2 times x minus 2, because we're centered at 2, raised to the 0 power, because that's the 0th derivative. That's strange to say, so your function, you haven't taken the derivative, so we call it the 0 derivative, all over 0 factorial, plus negative 1/4. X minus 2, because again, that's where you're centered, raised to the first, all over 1 factorial, because that's your first derivative, plus 1/4. X minus 2 squared, all over 2 factorial, again, because that's your second derivative. Keep going, plus negative 3 over 8, x minus 2 cubed, all over 3 factorial. Last one, plus 3 over 4, x minus 2 raised to the fourth, all over 4 factorial. If we clean this up, remember 0 factorial is really just dividing by 1. 1 factorial is also really just dividing by 1, so you don't have to worry about those. Again, anything here to the 0 power is 1, so this is really just a 1. For our first one, p sub 4 of x, we end up with just 1/2 times 1 over 1, which is just 1/2. And then minus 1/4, and then I don't need an over 1, and that's just going to be x minus 2. And now I have to figure out these numbers. 1/4 divided by 2 factorial. You can put it into a calculator if you need to. If we grab a calculator, I'm going to do alpha y equals for a numerator and denominator, and say 1 over 4. If I divide that by 2 factorial, remember for your factorials, you'd hit the number and then math, scroll backwards twice to probability, and then you hit the number 4 for factorial, and that's going to be 1/8. plus 1/8, and then x minus 2 squared. And then figure out for these numbers. Negative alpha y equals for a numerator and denominator 3/8, and then divided by 3 factorial. So 3, hit math, scroll to probability, hit the number 4 for factorial, hit enter. That's negative 1/16. And then we're left with that x minus 2 cubed. And then for the last one, 3/4 divided by 4 factorial, you do the same thing. Divided by 4 factorial, so math, scroll to probability, hit the number 4, hit enter, and that's 1/32 times x minus 2 to the fourth. So that's your fourth degree polynomial that mimics 1/x at x equal 2. And we can put this one into Desmos as well, and this is the last one I'll show you in Desmos. If we put this into Desmos, remember the given function was that 1/x, and we forced 1/x to be a polynomial, and remember we're going to be centered at 2, and the polynomial we got was 1/2, and then minus 1/4 times x minus 2, and then plus 1/8 times x minus 2 squared, and then minus 1/16 times x minus 2 cubed, and then the last one was plus 1/32 times x minus 2 raised to the fourth power. Now notice, if I'm centered at 2, this blue graph, which is the polynomial I'm building, is much like the red graph, the 1/x that I'm trying to be. The last one in this section is f of x equals the cubed root of x, n equal 3, and we have that we're centered at 8. So we know that c is equal to 8, n equals 3 means I need to go down to my third derivative, and the function itself is the cubed root of x. So if we make the table to organize ourselves, the cubed root of x we know we can write as x to the 1/3. What is the first derivative? Well, that's going to be 1/3 x to the negative 2/3. What is a second derivative? Well, that's going to be negative 2/9 x to the negative 5/3. Finally, what is the third derivative? Well, that's going to be 10/27 x to the negative 8/3. And we're evaluating each one of those at 8. So what is f of 8? Well, we're going to stick 8 to the 1/3 in a calculator. And then f prime of 8, well, we'll stick 1/3, 8 to the negative 2/3 in a calculator. F double prime of 8, negative 2/9, 8 to the negative 5/3. And then the third derivative at 8, 10/27, 8 to the negative 8/3. So let's grab a calculator and work all of those out. 8 to the 1/3, we end up with 2. The next one, 1/3, and then 8 raised to the negative 2/3, making that into a fraction, we have 1/12. The next one, negative 2/9, and then times 8, and that gets raised to the negative 5/3. Again, if you make that into a fraction, you end up with negative 1/144. And then our last one, 10/27, and then it's times 8 raised to the negative 8/3. You make that into a fraction, and you get 5/3456. Now let's build that third degree polynomial. That third degree polynomial would equal 2 times x minus 8, because again you're centered at 8, this is the 0 derivative, over 0 factorial, plus 1/12 x minus 8 to the first over 1 factorial, plus negative 1/44 times x minus 8 squared over 2 factorial, plus 5/3456, times x minus 8 cubed all over 3 factorial. Now if we were just to clean this up, remember this is really just 1, this is really just 1, and that's really just 1, so you can ignore all of those. So your third degree polynomial here is going to be 2, and then plus 1 over 12 times x minus 8. Here if I reduce between negative 1 over 44 divided by 2 factorial, it might be easier just to multiply 144 times 2 because we know that 2 factorial is 2. Because if not, the fractions get a little more complex in the calculator and it can't always turn them back into a fraction. So if we do that, we know that our denominator is going to be 288. That becomes negative 1 over 288 times x minus 8 squared. Same thing here. It's going to get a bit complex. So just go ahead and multiply these bottom numbers. 3,456 and 3 factorial. If you don't remember that 3 factorial is 6, you can go ahead and just write in 3 factorial. But 3,456 times 3 factorial, or 6, gives you 20,736. So that becomes plus 5, don't forget about your numerator of 5, over 20,736. And then that's x minus 8 cubed. So the third degree polynomial that mimics the cube root of x, centered at x equal 8, is this polynomial right here. That's it for Taylor polynomials and approximations.